Yeah, I think everyone can hear me clearly. So just a little bit self-introduction about myself. I've been doing iOS development for like my entire career, but recently, like last year, I joined OKX. I transitioned to more interesting like role, which is building and maintaining our CI/CD infrastructure. So this presentation, I'll be focusing on end-to-end testing on the iOS side. Here's the agenda. I'll give you some technical background, then I'll talk about the test framework we use. The next will be how we manage our device. Then I'll talk about our architecture, how it evolved from the initial version to its current state. Then I'll give you a glimpse of how our device farm in Singapore looks like. Then I'll show what benefits the end-to-end testing gives us. The last will be I'll leave some time for question and answer. So this is actually my favorite graph when talking about test. Like all developers know what it means. To like guarantee your software, to build high quality software, you need to have enough tests. Especially for OKX app, we have millions of users. Before releasing a new feature, we need to guarantee it doesn't cause trouble for our users. Unit test, we have, it's the foundation of a software system. OKX has a very high test coverage rate, unit test coverage rate, and also the integration test. So the next step for us was, last year, the focus was on end-to-end. So why we need to step further, why we have to do end-to-end, because our app is very complex. We rely on developer self-testing and QA manual testing before we introduce the automated end-to-end test. So to save cost of maintaining a big QA team and also to reduce the burden of developer self-testing, we invested a lot on automated end-to-end test. So before I joined, we actually had a few maestro testing on our CI pipeline, which was not very stable, and we decided to move away and move to a more stable test framework. So what we experimented was these two native test frameworks and cross-platform. The difference is that the one, as you can see on the other side, one test framework for each platform, and on the other side, you can support both iOS and Android using Appium. I was new to this framework. I had never done this, so that was a challenge for me. So why we eventually we choose Appium as our test framework, because it's open source and cross-platform, which means most of the time you just need to write your test case in, you just need to maintain a single set of test cases. But when you have to build, iOS and Android, they have discrepancies, UI discrepancy or like a custom platform features. It's like 10%, I would say. So for us, the cost of maintaining the test cases using a cross-platform technique is very essential. And the third point is Appium is client-server architecture. This is also very important because we plan to host our test devices internally. We don't want to use like a cloud-based device farm due to security concerns. And the last point is Appium. It's a very well architectured system. You can use different driver implementations. And for iOS, we use XCUI test framework. No, I mean the driver is called XCUI test driver. So this is a general architecture of Appium. I guess some of you might be more familiar with this. So basically, you have to talk to the device. You have to create a Appium client, which can be written in any general purpose programming language. And by the way, we use Python in OKX for end-to-end test. And the client can talk to the Appium server, and the Appium server will talk to your device through drivers. Before going to details of our architecture, just show you how we manage our device. We use an open source solution called the Sonic, sonicCloud.org. If you're interested, you can go check it out. So basically, install the server, Sonic server, on your server machines, which connects to multiple devices. And you authorize, enable developer mode, then you can see all your devices online. Like if you click Use Now, you can manipulate the device remotely. Okay, now architecture. So in order to run end-to-end test using Appium, you need 3 essential components. The first part is your test script, which is just some Python code that can talk to the Appium server. We use Appium Python client as the open source library that can communicate with Appium server. And the second is, of course, the Appium server. You need to get it running before sending commands to the server. And the last part is the device. And the device all the devices have to be connected to our server machine. So you just need these 3 to run the test locally. But for developers, we develop locally and push to CI to verify with code on development branch. And how do we put it on CI? How does it work? Okay, this is a more detailed version. So we use Jenkins for CI/CD purposes. So first step, we pull the code, which is the Python code, Python script. Then this is the initial version, by the way. Because Sonic, it not only just manage our device and let you open preview the device and operate remotely. It can also help establish the connection between the server machine and the devices connected through USB cable. So we use, in the initial version, we call Sonic to establish the connection to devices. And the third step, we initialize a driver object by passing it some configuration, like your server IP address and port number. So our code on Jenkins can talk to our Appium server. And then we send commands to trigger, like click this page, go to that page. Then we verify. The last step is to gather the reports. We use PyTest HTML to generate our reports, which I will show you later. So here, as you can see, the server machine is hosted internally. It has one Appium server process which service multiple clients. On the left side, Jenkins, each job acts as a Pum client. We can have multiple Jenkins job running at the same time. So the server will service all these requests. That's the initial version. Then we encountered quite a lot of stableness issues. Let me go back here. So the major issue we had is the connection between our physical server machine and the device are not stable. The Sonic agent internally uses Sonic agent, Sonic iOS bridge to talk to the device, which was not maintained well. It's an open source library, so it's not a very good high quality. So the connection was not that good. And the second headache for us was the Pum server. After running for a few weeks, it can encounter high memory issue. The server can just stop working, and that caused our end-to-end test running not very stable. So we improved our first version by adding a new customized end-to-end server. So here is the new architecture. You can see the difference is we no longer rely on the Sonic to maintain the connection between our server and the devices. Instead, we use a built-in Xcode tool called device control to launch the WebDriver app on the device. And we use iProxy to establish the proxy channel. That's one of the big improvement to make the connection stable. Second improvement was we no longer use a long-running Pum server process. Instead, for each test job, trigger from Jenkins. We don't talk to the Pum server directly. We ask our end-to-end server to launch a new Pum server process. You can see from here. Then we establish the proxy channel. Launch a Pum server, first step. Then we launch the WebDriver agent. The last step is to establish the channel. Then you have everything ready. You can send test commands from Jenkins and then generate reports. Actually, we have another version after this. We've introduced the parallel, but I cannot cover everything here. So this system is currently running very smoothly. Test report. Sorry, guys. This is what test report looks like. As I mentioned, we use PyTest HTML, an open source plugin to generate the report. And we have customized this plugin to show extra information for developers to check out what happened, what caused the failures. You can see, we capture screenshot. And we also have the option to enable screen recording. I'll show you later. And we also output for iOS, we output the view debug tree and the console log. Of course, if there's a crash, we can also catch that, and there will be a crash link here. You can have an overview of the whole test process. Here is a video linked from screen recording. Quick. Yeah. By the way, when the test is running, you can also we also support live streaming. That means you can see this video streaming while the test is running. And when the test finish, we save the video in our internal storage. You can check later. Okay. That's pretty much what we built in the last few months, and just to showcase what our device farm looks like. This is our Singapore device farm. We have other device farm as well. We have around 10 Android devices and 13 iOS devices. So we have 2 Mac Mini as host machines. Each one connect to a device of each platform. And how does it benefit the OKX? After we made the end-to-end testing infrastructure stable, we integrated to our multiple CI/CD pipelines. Here is one of them. It's the CI pipeline. We built it like it's a scheduled pipeline. We build the code, do some static code check, then we run unit test, then we run our end-to-end test. Now, we have other pipelines, which is not shown here. Like when you try to merge code to the development branch, that will also run the end-to-end test. The difference is for MR pipeline, we only run the production cases, which means the app is connected to production environment. You have to use some prepared production accounts to test. Just to speed up the process, we don't run all the cases. We have production case and sandbox case. Sandbox case, the app is connected to the test environment. Here in the CI pipeline, as I said, it's a scheduled pipeline. It's triggered like every few hours, and so we run all the test cases in this pipeline. So for the last few months, we've written around 200 sandbox cases and 20 iOS production cases and 80 production cases. We've caught 30 in total, 30 bugs and crashes before the app went into production. Most of them are UI bugs and unexpected feature behavior changes, like people change the behavior of the app, but they didn't update the test script. We will block such merge request. And also crashes. We also caught a few crashes in the pipeline. And the last thing, which is very hard to notice when your app behave like some critical networking code, like people introduce bugs in some critical infrastructure code, and the app suddenly starts querying backend multiple times without caching. And we caught 2 such issues because I didn't mention we had a monitor on our server, on our Mac Mini servers. And we notice abnormal network bandwidth consumption. So we went to check the code, and yeah, that's how it helped us avoid some big issues. Okay, in the future, we plan to add more features to our end-to-end infrastructure. So first of all, app performance is very important for us. We do have app performance tracking. Like you guys might be very familiar with Firebase. You can see like page load rate and the networking failure rate, such things using Firebase. But we would like to, that's when you release, after you release your app to the App Store, we would like to have more insight on these app performance metrics before we even release the app. So without end-to-end, you have to rely on the data from the development build triggered by QA or developers. After we got this in our pipeline, we will have more app performance data generated from our test build. And in next step, we will integrate this app performance metrics in our test report. Yeah, second, we might have built our own report system. Instead of the one I shown here, it's not that fancy. We would like to make it fancier. Third point, we'll make some of the test code more efficient because the test code is contributed by different business squads, right? Not all code are that efficient. They sleep when you try to locate an element. You sleep, you give it a fixed timeout. That causes the whole process less efficient. So we'll provide more efficient utilities code for all business squads to use. And the last thing is better device scheduling, because our pipeline, the whole system here supports running tests in parallel. The 200 tests, we don't just run it on one machine. We split up and dispatch each set of test cases to different mobile devices. If we run all 200 cases on one machine, it will be 2 hours or more. But now it just like the best case, 2 hours divided by 10, let's say. That would be, sorry, my mathematics is not that good. You know what I mean, right? So, but there is an issue when we schedule the devices. Some devices are we dispatch more jobs on one device than the other, so we need to introduce a more efficient device scheduling mechanism, a strategy, I would call it. So that's all. I hope you guys can learn something, or as I mentioned, I'm new to this area. You guys, some of you might be more familiar with the PUM or end-to-end test. Yeah, if you would like to contribute, you can check out our job on LinkedIn. We are hiring a lot. Any